going to simplify radicals for 2 days. So today would be simplifying radical expressions day 1. And the directions are to simplify. So you start with the first problem, and I say, what's the square root of an 8? Square root of 8. Remember me telling you that you really needed to memorize all your perfect squares and perfect cubes, right? So today, it really will help. And I can't take the square root of an 8. The square root of 8 doesn't work. It's not a perfect square, right? But you can simplify it. Right? By simplifying it, you look through all your perfect squares and glance over at them, and you look at the biggest perfect square that fits into 8. What's the biggest one? 4. So you can rewrite this as the square root of 4 times 2. And I can take the square root of 4. The square root of 4 is what? 2. So you take the square root of 4 and it basically kicks the answer out, right? Because you're taking the square root of 4. So then the answer is you took the square root of 4, so you have 2 on the outside. And this 2 couldn't be simplified anymore, so it stays under the radical. So the answer is 2 root 2. You can actually check it. Okay, you can kick, if you think about it, if I wanted to put this 2 back in the square root, I would have to square it, wouldn't I? So 2 squared would be 4. So to go back in, it would be a 4. 4 times 2 would be 8. Okay, let's look at number 2. The square root of 80. The square root of 80. This one's a little harder because you might not naturally just see something that fits into 80, but look at your perfect squares and see if you can figure out what fits into 80. What perfect square? Not perfect cube. Yeah, it's the square root of 16 and 5. So you rewrite it as 16 times 5. Okay, I can take the square root of 16, so it's gone. And to kick it out, you would end up with a 4, right? Because that's the square root of 16. The 5 was still left inside, so 4 root 5. And I'm writing it out to the side, okay? But guys, pretty soon you guys will be good enough at this that you'll look at 80, and you'll be like, all right, 16 times 5, the square root of 16 is 4, so it's 4 root 5. You can just kind of write it below there as well. I'm just giving you notes so you can kind of work your way through a few to process it. Number 3. I have 4 times the square root of 54. Now, yesterday I talked about this, and I'm just going to do it on a side note for a second. You notice that 4, be careful. There's a difference between this 4 written and this 4 written. Do you see the difference between the two? Yeah. This is the 4th root of 54, and this is 4 times the square root of 54. So be careful about the placement of your 4s, especially like on an answer, a quiz, or a test, if you get in a hurry. If it's a root, it needs to be small and up high. If you're multiplying, it needs to be outside and in front. Okay, there's a difference between the two. What fits into 54? What perfect square is going to fit in? 9. All right, now this one's different. There's already a 4 sitting out there. So you're telling me that this is 9 times 6. The square root of 9 is 3. Now watch. If I take the square root of 9, I get 3. That means I'm going to kick a 3 out here. There's already a 4 there. So you're going to have to take the 4 and you're going to have to multiply it by the 3 that you're kicking out. So see what I just did? So there's a square root of 9 is 3. I'll kick a 3 out. There's already a 4 there. So 4 times 3 is 12. So now you have a 12 root 6. Number 4. The cube root of 24. The cube root of 24. Now instead of looking at perfect squares, you look at your perfect cube list, right? The perfect cubes are 8, 27, 64. The list gets big fast. So what fits in here? 8. So the cube root then would just be 8 times 3. You can actually take the cube root of 8. So 2 cube root 3. The 3 stays inside. Number 5. With the fourth root of 32. And they're real short like this. You can write them underneath. Look at your fourth roots. You have 32. And what else do we have? Oh, I'm looking at the wrong side. I'm sorry. You have 16. Does it fit in? Sorry, guys. I was looking at the wrong thing. The fourth root of 32. What fourth root fits in? 16. So this is the same as 16 times 2. Correct? You take the fourth root of 16, which is 2. And you're going to have 2 fourth root of what's left inside there. Right, we weren't able to do anything with that 2, so it stays in. You're just simplifying them. You're breaking them down as much as possible. Number 6. If you're asked for the square root of 125 times x to the 4th, y to the 5th. Now this one, let's rewrite to the side because we've not done one like this before, and it's a little harder. I'm going to rewrite it inside here. Let's think about it. The easy part is the 125. What perfect square fits in the 125? 25. Okay, so then we're going to do 25 times 5. So that's taken care of. Now, we learned yesterday from the warm-up. Here I've got x to the 4th. Okay, and this is a square root. There's a 2 here. How do I solve this? In fact, look back at the warm-up. We had 6 and a 3. What did we do to those two numbers? We divided them. Okay, same here. A 4 divided by 2. So can I solve this? The square root of x to the 4th is x what?
Squared.
Yeah, x squared, because 4 divided by 2 is 2. So that number, that variable x, we don't even need to worry about. We can simplify it just like it is. We don't have to break it down. Kind of like we broke down the 125. We don't have to break down the x. It's easy. But, of course, the y is not as pretty. Can I take 5 and divide by 2 and it be pretty? I'm not done yet. I haven't taken the square root. I left it alone. They're asking why did I put, look, it's still under the radical. So I just left it. Okay, now here, y to the 5th. Can I do 5 divided by 2? No. So I need to rewrite it into something like I rewrote 125 into 25 times 5. So the way you think about this is you ask yourself, what's the biggest amount of 2's that can go in? I can put 4 2's, 2 times 2, right? Or 2 plus 2, sorry. So I can rewrite it as y to the 4th, okay? And how many y's are left over? 1 times y. Isn't that the same as y to the 5th? Just like 25 times 5 is the same as 125. We sure are looking different. So I'm going to rewrite it over here as y to the 4th times y. And now I'm going to actually simplify each one. What's the square root of 25? 5, so kick out the 5. Can I do anything with the 5 that's left inside? No, I'm going to circle it because you'll forget it if you don't. The 5 stays inside. X to the 4th, 4 divided by the imaginary 2 there is 2, so that becomes x squared. Go to the y. 4 divided by 2 becomes y squared. And there's a y left over. So what's left inside? The 5 and the y. If you didn't quite understand that, I'm going to do 2 more kind of like it to help you out. Here's number 7. 7 is the cube root of 54 times a cubed b to the 7. Look at your perfect cubes. Can I break up 54? What fits into 54?
8.
No. Okay. What fits in? 27 and 2, right? So I'm going to go ahead and write this one out. Okay, 27 times 2. The 54 is done. Do I need to mess with the a cubed? Is it pretty or not? Do I need to mess with it? 3 divided by 3 is 1. It's good, right? So I'm going to leave it as a cubed for now. I'm not going to mess with it yet. What about b to the 7? Can I do 7 divided by 3? No. What's the closest number without going over 7 I can divide by? Right, so this is the same thing as b to the 6 times b. So that's what you're going to put in there. B to the 6 and b. You're just rewriting it. Why do I need to add the b? Why do I need b6 and b? Why do I have to have both? Yeah, how many b's do I need? So I can't change the value, right? I'm just rewriting it to look different so that I can simplify it. I still need 7 b's. All right. So now then, take the cube root of 27. What's the cube root of 27? 3. What's the cube? Can I do anything with the 2? No. What's the cube root of a cubed? Excellent. A. Cube root of b to the 6th? B squared. And I can't do anything with b. So left inside, or what's left inside? A 2 and a b. Excellent. Great. 3 is the 4th root of 48 x to the 5th y to the 8th power. I'll give you a second to try it. We haven't had to memorize too many 4th roots, right? So what fits in?
16.
Okay. So if you leave what's here, we're going to write 16 and 3. Okay? And then for x to the 5th, you should have rewritten as x to the 4th and another x. Does that make sense? Did you have to rewrite y to the 8th? No, because 8 divided by 4 already works. So I didn't have to rewrite that. When I take the 4th root of 16, you get 2. When you kick a 2 out, though, there's already a 3 there. So you have to do 3 times 2, which is 6. The 4th root of 3 is, you have to leave it in. On x, the 4th root of x is, 4th root of x to the 4th is x. Sorry. Leave your x alone, and the 4th root here would be y to the 2nd power. Now then, write what's left inside. Be sure to circle what's inside, because you'll be careful, you'll accidentally scan over and forget something. So then 3x is what's left, sorry. 3x. Okay, so we're done simplifying, right? Now we're going to add and subtract. When you add and subtract a radical, their tails have to match. Okay, so you have to make sure that they have the same tail in order for them to work. Okay, so let's try. Can you look over me? Probably yeah. Here's adding and subtracting. You can only add and subtract like radicals. Okay? You can only add and subtract like radicals. Let's give one a shot. So if you have 2 root 2 plus 3 root 2, what do you think the answer would be? It's kind of like saying 2x plus 3x. Does that make sense? They have to have a like tail, or whatever you want to call it, but the ends have to be the same. The radicals have to be the same. So what's 2 root 2 plus 3 root 2? Good. 5 root 2. How about 3 cube root 7 minus 4 cube root 7? 3 cube root 7 minus 4 cube root 7. Alright, what's 3 minus 4? Negative 1, right? So it's just going to be negative cube root of 7. Three gets a star by it. 2 root 20 minus 2 root 45 plus 3 root 80. Okay, it's asking me to add and subtract. You can't add and subtract unless you have like tails, right? Okay, and or like radicals, whatever you want to use. So why don't you practice simplifying those first? You're going to have to clean them up. Clean them up and see if I can put any together. If you want, you can just write right below them. This is 4 times 5, right? You take a 4 out, it gives you 4 root 5. You don't have to rewrite them all. You can try it underneath if you'd like. This is 9 times 5. So you multiply that by 3, so you get negative 6 root 5. What about 80? It's another one you're going to see that nothing comes out right at first. Okay? You've seen 2 now. You've seen 60 and 80. What fits into 80 though?
16.
Yeah, it's 16. Okay, so it's 16 times 5. Square root of 16 is 4. There was already a 3 out there, so 3 times 4 is 12. Now they all have the same tail. They've simplified, so you can put them all together. You do 10 root 5. Okay, so we have added and subtracted. So the next step would be to multiply. And if you're going to multiply, then you have to multiply coefficients. And, so in other words, you multiply coefficients. Those are the numbers outside. So a quick way to think about that is you multiply the outside numbers together, okay, and you have to multiply what's under the radical. Then simplify. So in other words, I like to say you take the outside numbers and multiply them together, you take the inside numbers and multiply them together, and then simplify. Does that make sense? All right, let's give one a shot. They don't have to match, you just multiply. So number 1, square root of 3 times the square root of 2. You would not be able to add those, but you can multiply them. The outsides are just 1, so 1 times 1 doesn't change anything. The insides are a 3 and a 2, so the answer is what? Root 6. Number 2, root 2 times root 2. Root 2 times root 2. Which would give us the square root of 4, right? But you can actually simplify that. What's the square root of 4? 2. Excellent. Okay, the next one. The cube root of 2 times the cube root of 4. Does the cube root of a number times the cube root of a number become the 9th root? No, the square root didn't become the 4th root, right? You just multiply outside numbers, inside numbers. What radical it is doesn't matter. What root it is doesn't make any difference. So this just becomes the cube root of how much? 8. which can be simplified. The cube root of 8 is 2. You don't have your perfect squares, perfect cubes, your 2 to the 4th, 3 to the 4th, then 2 to the 5th, and 3 to the 5th memorized. You need to memorize them. All right, the next one. What if we did 2 times root 3 is 4 times root 3? Outsides, insides when you multiply. So 2 and 4 make 8, and 3 and 3 make 9. But you can simplify. The square of 9 becomes 3. The answer is actually 24. Number 5. 7 square root of 6 times negative 3 square root of 10. Outsides, insides. Start off with negative 21 root 60. 80 and 60 have both come up. Can you simplify 60? Can you simplify 60? Mm-hmm. Yeah. What's it turn into? 4 and, yeah, no, that's okay. This is 4 and 15, right? So the square root of 4 is 2, so you're going to take 21 times 2. Make negative 42, and the 15 stays inside. Number 6. 5 plus root 3 times 2 minus root 2. What does this mean? Binomial. Yep, you gotta FOIL it. Try it. A 5 and a 2. Okay, if you struggle with this, watch. A 5 and a 2 is going to give me 10. But this is actually different. This is a 5 and a negative root 2. Right? That root 2 is negative. So you're going to, outside numbers stay outside. So negative 5 root 2. Questions on how I got that one? Because there's like an imaginary 1 here, right? So negative 5 times negative 1 is negative 5. And then root 2 stays inside. Now go the other way. So that would be plus 2 root 3. And lastly here, be a negative root 6. Watch your signs. And then you check and see. A root 2 and a root 3, root 6, can't put anything together, can't simplify anything, you're done. Here's negative root 6 times 4 root 3 plus 7 root 5. There's no foiling, which you're going to distribute. It's the same thing, right? Outsides, insides. First one would be negative 8 and 18. Next one would be negative 14 and 35. Oh, 30. Thank you. I'm sorry. Can you change anything up? Wait, yes you can. Come on, guys. Can you change anything? Yep.
Oh, yeah.
Yeah, y'all see it? It's sneaky. Sometimes they are sneaky. You have to be careful. You don't want to lose points. Can I change? Which one can I fix?
First.
Yep. This is the same as 9 times 2, right? So therefore, you take the square root of 9, which is 3. There's already an 8 out there, so negative 24 root 2 minus 14 root 30. You got to be careful. If you want full credit, you got to go all the way down to here. Number 8. We're going to 10. Yeah, we have 3 more. We're going to number 10. So we have root 10 minus 2 root 6. And then root 5 plus 4 root 3. Again, this is another what kind? Yeah, so you have to factor it, right? Foil it, sorry. You have to foil. So you foil and see what you get. Give me a second. Doesn't matter what order you got it in, as long as the signs are correct. Is that what you got, though? Okay, but do I need to leave it like that? No. Clean it up, yep. The 50 and the 18, clean up. Does the 30 clean up? No. Simplify it more. You gotta always be looking for that, okay? So this is 25 times 2, which is just 5 root 2. These you can't simplify, but you can put them together. So plus 2 root 30. This is 9 times 2, which is negative 24 root 2. Can I put anything else together now?
Yeah.
One last thing, right? The 5 root 2 and this one. So 2 root 30 minus 19 root 2. It doesn't matter which order you put it in, as long as your 2 is positive and your 19 is negative. Outsides and sides. 3 and 7 make.
Oh.
That's right, 21. You're right. 3 and 7 make 21. Okay, and on the inside I have a 6 and a 2, which makes 12. I have 2 x's, which we're going to use x squared, and I have 2 y's. Now let's clean up the answer though. Remember, it's a square root, correct? So 12 is 4 and 3. Square root of 4 is 2, so you have 42. Leave the 3 inside, and you have an x and a y. Left with the square root of 3 inside. The x and the y, technically, you guys have to be absolute value. They don't really come across one like that today, but don't they? 2 and 2, they're variables, right? It could be negative if they're in closet.
So if you don't put the absolute value on the test, you're going to -1.
Oh, yeah, like minus 1 point. Yeah, not like the whole problem or anything. Okay, last problem for today. Give it a shot. A plus the square root of b squared. This is your can you get it right question today. Your Jeopardy question. This is not a squared plus b. Right? Drats.
Wait, what?
Okay? It's not a squared plus b. Okay? And because so if you see a square, guys, it means you have to write the problem twice. Okay? you can do it in your head too. I don't know if you have seen this done before. You multiply these together, you square the first one, a squared. You multiply them together, which would be a root b, and double it, okay, which is plus 2a root b. And then you square the last term, which is b. That's the fast way. Square the first one, multiply them together, and double it, and square the last one. That's your little shortcut. But if you choose not to, you can FOIL the whole thing out. A squared plus a root b, plus another a root b, plus b. Okay? Have to FOIL them out. Write them twice. Alright, that's all for today.